Hey everybody, this is Larry. This is week 4 of the weekly premium challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Apparently we did it recently enough that it's still in cache. But yeah, let's take a look. Today we have 2852, sum of remoteness of all cells. Was this like a contest problem? Why would it be premium? What, did I work on premium stuff? Maybe I did, I don't know. Anyway, yeah, you're given a 0 index matrix grid of n by n. Each cell of this matrix have a value of ij, positive or negative 1 representing a block cell. You can move from a non-block cell to any non-block cell that shares an edge. For ij, we represent as remoteness as some whatever, okay? If the cell is ij, non-block cell, R sub ij is the sum of values grid sub xy such that there's no path from the non-block cell xy to this ij. Okay, I mean that. What does that mean? Initial value. So then we have block cells, or because basically it is the sum of all the cells that it cannot connect to, right? So that already just thinks about what's it called? Connectiveness or whatever, right? Connectedness, whatever. There are two ways that you could probably think about this from, or I mean, this basically what I said is the one way. What I mean by that is implementation wise. And implementation, you could do it with the union find way and just kind of draw out the blob, or you can just do it with a breadth first search or depth first search, whichever you prefer. Yeah, and the idea with the breadth first search is just that, depth first search is that you only really care about, you really only care about the components, right? Yeah, it doesn't like, and the thing is that the inverse of what you want is very easy to calculate, right? Because basically, what you have when you do a connected component search or a component search, when you do one of those, it gets you all the values you need, and then the sum of all the numbers is the universe, and so you just subtract that to get all the opposite numbers. So very simple things, honestly. So I think that's what we're gonna do. So let's get to it. Do I want breadth first search or depth first search? I don't know, it doesn't really matter. Let's do breadth first search. I mean, I also could do union find or disjoint set union, but it's fine. I don't know. I mean, it's the same idea mostly, right? So here, okay. So then let's just say total is equal to 0 for x in range of R, for y in range of C. We have but only if it's not C. Oh, no, it's -1. Okay. No, not -1, obviously. Oops. Already making mistakes. And then now, yeah. And there are a couple of things that you have to be careful about, but honestly, not too bad. Because if you're not careful, you can go into an n square thing, but we'll go over it. And n square, I mean, n is the number of cells, not n as the input as here, which is an n by n. So if you do n square, it's so hard to say. If you do it, use a quadratic time algorithm, it's going to be too slow because there's 300 times 300, which is 90,000 number of cells, right? If you do that square, it's too slow. But if you use linear in the size and input, that's fine. And that's what we're going to do. So yeah, so here maybe we have, right, for x and maybe just like a done thing, right? Oops. Times C, right? So then now, yeah, if not done XY, then maybe just want a BFS XY, right? Start from here, and yeah, and that should give us the answer. Maybe we can even load the answer into it, but that's whatever. Let's just go to result because that's what it is. I like to. The reason why I like to use none in these cases is because, at least in the debugging, or hopefully I don't need to debug and it's just correct, right? But if I need to debug, it'll tell me that, instead of me getting confused of like, oh, is that a 0? Is that a real 0? Is it a fake 0 or whatever? This will let me know, right? I think actually maybe I'll do a quick scan on what is it? If grid of xy is equal to -1, then what's it called? Is equal to 0, and then we continue, right? So this is only on non-blocked cells. We have xy, so let's just go to xy for starting, and this is just going to be for our first search things, and we don't really care about the distance, but so it's just connected components, but we do care about two things, right? Well, one is the sum, as we talked about. Hopefully that's what drive is, but also the number of nodes, right? Because the number of nodes will dictate, for example, here, okay, whatever. If you look at the 5, sure, the 5, maybe that's a bad example, actually. This is a better example, maybe, right? Because you have the 3 and the 4 in the corner. Well, the 3 will be like, oh, the sum of all my connected components is 7. And then for the 4, you would say the same thing. But then if you just be able to count the number of cells, then now you have a better idea of, you know, just things in general. But I guess you have to still, but yeah. And I would also say that everything in the same component has the same answer, right? Hopefully that part is obvious, because, you know, you could just, it's just by definition, literally, right? So yeah, so maybe current total is equal to 0. Q dot append sx sy. Yeah, and then maybe we do want it. Xy is equal to I thought I had it, but okay, fine. Directions again, up, down, left, right. I say again, but you didn't see it. It's because the daily problem was also this. If, and maybe some of you could have watched that video. I'm just saying, like, but that's why I'm saying again, and not like in a weird, awkward Twilight Zone deja vu kind of way. But yeah. But I am typing the same thing again from that video. If you want to check that out, that's fine too. I don't care. And was it grid of, where did D come from? Then, okay. So we want to say, whenever we pop, we just want to add, and you could do that on NQ as well. You just have to be consistent. What's it called? Grid XY, right? Actually, then you don't need the number of nodes per se, but anyway, and done. Okay, what am I doing with this? Oh yeah, we want to just q dot append nx and y, and then in theory we should be mostly done. We don't even need to return anything really. We just need to so we have current, and then now we have to look at each cell that we just colored, if you will. How do I want to write that though? I mean, there's so many easy ways to write it. I'm just kind of thinking about it. Maybe we could just have like just have to keep track of it, really. Yeah, I mean, maybe you could. Now you have to do it in a linear way. You can't just be, or linear in the output sensitive kind of way, because otherwise then it would also escalate to n square. You have to be careful with the amortization stuff, but that's okay. Yeah, then maybe just like it's not really the answer, but yeah. And then now for x, y in answer, did I also call the other thing? No, I called a result, which is actually confusing. But yeah, is equal to total minus current, and that's it. Hopefully. Did I miss something? Oh, that's okay. So I misread this. I thought you're supposed to return the grid, which is what I was doing. That's okay. So we don't have to do that, which is actually makes things a lot easier. I think that's, I got confused along the way, but this is how you do it if you need to return the grid, but apparently you don't. So then now, yeah, so then now it's even easier because we don't need this. We don't need this, but then now this is where you count the number of nodes, right? So current nodes is equal to 0. Yeah. And then now the contribution, right? So so total minus current is per node, so it's just this times nodes, right? It's the contribution to the final answer. So you have let's just go to res, and because that's what we have here, and we just have it as 0. Oh, okay, actually then we don't change that. Int object not editable. Oh, I must have a oh, that doesn't do anything, so okay, fine, because we don't need it anymore. Okay, it's good for this one, fine. Where I get wall? Total minus current equal to node. So is this one, right? So they think it is 13, but I think, or my code anyway, thinks it's 19. Why does it think it is 19? So it 02. Why does it do 02 twice? Oh no, it's not the. That's just. But that means that we obviously did something weird. Did I not put done? Oh, I forgot to do done, huh? I think I was on this code and then I got distracted about something and then I just stopped doing it. I don't know what it was now. But very easy things to fix, but also very silly mistake to make. Yeah. Give a quick submit and that's it. Pretty okay, pretty straightforward. I do want to anyway, so yeah, with this complexity, what is it, right? Well, we kind of touched upon it very briefly, which is that it is linear in the size of the input, because the way that we structured it, every cell does get looked at all at one time, right? Roughly speaking, or at most 4 times if you really want to be more strict, because each cell can get visited by the upper neighbor, left neighbor, down neighbor, and the right neighbor, right? So that's it. Yeah. That is all I have with this one. Let me know what you think. Yeah. Just maps. What did I do last time? I don't know why we wrote it this way with the count, but because you could have calculated directly, but I guess it's a little, I don't know, maybe it's a little bit cleaner. I don't know if that's true. But yeah, I don't know if I did it as a contest or whatever, but anyway, that is all I have though. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.